Hello everybody, welcome back to page 4 of our final review. We're going to use triangle relationships to classify triangles and solve problems based on their angles and sides. So first thing I would do when I'm looking at this triangle right here, I notice that it is an equilateral triangle. And since it's an equilateral triangle, all the sides would be congruent to one another. And so I can set up an equation if I need to find the value of x, where I set any two sides equal to each other. I don't need to use all three sides. I'm going to actually pick the 6x minus 8 and the 5x minus 1 to set equal to one another. I don't know why, I just felt like it. I didn't feel like using 13. 13 kind of scared me. I don't know. Anywho, I'm going to add 8 across the equal side. That gets me 6x equals 5x plus 7. And if I subtract 5x, then my x comes out to be 7. And so if that is my value of x, I could go and check and make sure that this would work. This side would be 5 times 7 minus 1, which is 35 minus 1, which gives me 34 in there. So we should get 34s for all of these guys. 6 times 7 minus 8. 6 times 7 is 42, minus 8 is 34. And then over here, 3 times 7 plus 13. 3 times 7 is 21. 21 plus 13 is 34. So that worked out. That 7 is the correct answer. All right, on the next one, we want to draw the transformation and describe the transformation. So they gave me this rule x negative y. And so I'm going to first list the ordered pairs that I have. K is negative 4 and 8. And I'll fix that in just a second. M is negative 1 and 1. And L is negative 7 and 4. Yeah, fix this. Negative 4. There we go. All right. And so now I'm going to transform these guys into a new prime value following the rules that is given to me up above. So when I transform them, it says x negative y. So the only thing that's changing is that my y goes from whatever sign it is to its opposite sign, and the x's remain the same. So negative 4, negative 8. Down here, negative 1, negative 1. And L is negative 7, negative 4. So if I plot these points, if I go back 4 and down 8, that guy will be my K prime. This will be my image, negative 1, negative 1. Oop, it was negative 2, sorry. You're probably screaming at the video, negative 2. So it's back 2, down 1, so that puts M prime right there. And then last but not least is negative 7 and then negative 4, which would be L prime. And so then if I connect those lines, connect those dots here, you can see that I end up with the same triangle. But then the question is, what kind of transformation did I just do? Well, the type of transformation that I did, it looks like I just flipped this thing across the line. So I'm going to call it a reflection across the x-axis. And then finally, the final learning target for this one was about congruent triangles, and so we need to prove these triangles congruent to each other if we can. All right, so first thing is triangle STR. I do have a couple things that I know. I know that TR is congruent to QR in the two different triangles. They're marked. I also know that oops, let me already fix that. I'm supposed to be writing the S there. That TS is parallel to PQ. Okay, so you don't have to go through all of this, but this is kind of my thought process of what's going on as I'm doing this problem. So I just thought I'd write it down. Since these guys are parallel to one another, that means I can get angles congruent. I can also use vertical angles, and that would also get it. So right now I have a side congruent. So when I'm doing this, I have a side. So my options when I have one side is either side, 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 or side, angle, side, or angle. Yeah, actually, all of them will work with one side. Angle, side, angle, or angle, angle, side. Those four, because I have one side congruent, could be my reasoning for there. So I got to narrow this down a little bit since I have a side given to me. I have to come up with something else. Well, like I said, I can use vertical angles, and I think that would be the way I would go about this one. I would say that angle right there is congruent to that angle right there. So angle PRQ on the top triangle will be congruent to SRT by vertical angles. Okay, vertical angles. So now, in my markings here, I have an angle. All right, so I have a side. I'll put side over here. I'm going to get rid of that one over there. I don't like it. This guy's kind of getting in my way here. That one's terrible, so let's fix this all up. So I have a side and an angle. So right now, that guy is out. So I have a side and an angle. All of these guys have a side and an angle to it. So the question is, where is my next angle going to be? And since I have parallel lines, if I choose, and it just depends on what I choose, if I choose this angle S to be congruent to angle P, then if I go that way, angle S is congruent to angle P, and then that's by alternate interior angles, then that would mean that it would be angle, angle, side. Okay, so that would mean that the triangle STR would be congruent to PQR. And if I did it this way, it would be angle, angle, side. Now the other option is if I would have picked the other angle over here, and the angle over there, for alternate interiors, same reason, if I would have done angle T and angle Q instead of these two, then my reasoning would have been angle, side, angle, because the side was squeezed between the two angles. But in this case, I didn't. I chose angle, angle, side, so that's the way. But it wouldn't matter on the test. All right, so this concludes page 3.